take sine x equals a half. Because the sine wave rises and falls forever, it reaches the height 1/2 not once, but over and over. So the equation has infinitely many solutions across all angles, and usually several inside any given interval. But your calculator's inverse sign only ever returns one of them, the base angle. The whole skill is taking that single answer and finding every other solution that lives inside the interval you were asked about. Miss one, and you lose the mark. Here's the trick that never lets you miss one. Draw the trig graph over your interval. Here, sin x from 0 to 360 degrees. Then draw a horizontal line at the value you want, y equals a half. Now every point where the line crosses the wave is a solution, and you can literally count them. Here the line cuts the curve twice, at 30 degrees and at 150 degrees. 2 crossings, 2 solutions, nothing hidden. The graph turns a memory problem into a counting problem. You can get the same answers without drawing, using the wave's symmetry. Step 1. The base angle from the inverse function. Inverse sine of a half is 30 degrees. That's your anchor. Step 2. Use symmetry. Sine is positive in both the first and second quadrants, and the second quadrant partner of any angle is 180 minus it. So the other solution is 180 minus 30, 150 degrees. And if the interval ran further, you'd add 360 to each to collect the next cycle. Base angle, then symmetry. That's the recipe. Each function has its own symmetry partner. For sine, the second solution in a cycle is 180 minus the base angle. For cosine, which is symmetric about the horizontal axis, it's 360 minus the base angle. Those are the two you must know. Tangent is the simplest of all. Because it repeats every 180 degrees, you just add 180 to the base angle for the next solution. No reflection needed. And whichever function it is, once you have a cycle's worth, keep adding or subtracting full periods to sweep up every solution in the interval. Solve cosine x equals minus 0.5 between 0 and 360 degrees. First the base angle, always from the positive value. Inverse cosine of 0.5 is 60 degrees. Now cosine is negative, and cosine is negative in the second and third quadrants. The second quadrant angle is 180 minus 60, 120 degrees. The third quadrant angle is 180 plus 60, 240 degrees. Both lie in the range, so the solutions are 120 and 240. Base angle from the positive value, quadrants from the sine. Every solution, none missed. 3 traps. 1, the big one. Never stop at the single value your calculator shows. The question wants every solution in the interval, so hunt them all down. 2, always take the base angle from the positive value, then use the sign to decide which quadrants the solutions live in. And 3, the subtle one. If the equation has a doubled or shifted angle, stretch your interval to match that inner angle before you solve, then convert back. Otherwise, you'll silently drop half the answers. Mind those 3, and you'll catch every solution, every time. So a trig equation isn't one answer, but a whole family, because the wave repeats. Find the base angle from the inverse function, then use symmetry and the period to sweep up every solution in your interval. Check the graph, and you'll never lose one. Next, the trig identities. For more, that's MarkScheme.app.